On June 18, 2024, a hardware company reached a market valuation of $3.34 trillion. In a single day of trading, it became the most valuable public company on Earth. They surpassed Apple. To put that into perspective, Apple is a corporation that managed to sell premium smartphones to roughly one-third of the global human population. They eclipsed Microsoft, too. They achieved this scale without a social media platform, a search engine, or a flagship consumer device in your pocket. The company is NVIDIA. If you browse the web today, you are interacting with their technology. Their hardware powers Amazon Web Services, providing the physical infrastructure for nearly 30% of the cloud-based internet, alongside the world's most capable artificial intelligence models. Today, they operate as the monolithic architects of modern computing. But the structural logic that supports this entire empire was drafted decades ago, inside a remarkably small, fragile space. We have to step away from the sterile, sprawling server farms and go back to 1993, to a local Denny's diner. 3 engineers sat in a cramped vinyl booth. They had no venture capital. They were drinking cheap coffee, trying to figure out how to solve a massive mathematical problem in computer science. One of them was Jensen Huang. In a bit of poetic irony, he used to work at this exact Denny's as a waiter's assistant. Now he was a designer trying to bypass a physical limitation in microprocessors. The limitation was with CPU, or Central Processing Unit, which is a computer's main chip. In 1993, a CPU processed information in a strict linear sequence, solving only one calculation at a time, which created a severe bottleneck for highly complex tasks. Sitting in that booth, the 3 men sketched out a new hardware architecture on a paper napkin to bypass this exact bottleneck. They decided to call their unproven company NVIDIA, drawing from the Latin word for envy. They realized that the future of computing didn't lie in making one processor work faster, but in teaching thousands of smaller processors to work in unison. It was a blueprint for a machine that didn't exist yet. Their first major hardware victory arrived in 1999 with the release of the GeForce 256. They marketed it to consumers as the world's first GPU, or graphics processing unit, a dedicated chip built specifically to handle visual rendering. The secret to the GPU is a concept called parallel processing. Instead of forcing heavy calculations through one narrow channel, parallel processing divides a massive task into thousands of tiny parts and solves them all simultaneously across a vast grid of cores. The GPU had successfully offloaded the rendering burden from the CPU, allowing for a new level of complexity in virtual worlds. But the mathematical logic behind these graphics was about to be applied to problems that had nothing to do with gaming. In 2006, NVIDIA took an existential financial risk by releasing CUDA. CUDA stands for Compute Unified Device Architecture, a software platform that allowed outside developers to program NVIDIA's gaming chips for entirely non-graphics tasks. Adoption was explosive. Because developers could now access the raw mathematical power of a GPU, NVIDIA's hardware became the standard tool for modeling cancer proteins, running financial simulations, and mining early cryptocurrencies. CUDA was a brilliant trap. By building an easy-to-use software bridge that let anyone harness parallel processing, NVIDIA quietly embedded its specific hardware as the unavoidable foundation for the impending artificial intelligence boom. Fast forward to the modern AI arms race. When companies deploy heavy language models like ChatGPT, or when Tesla trains its self-driving algorithms, they require monstrous processing power, and NVIDIA is effectively the sole provider of the chips that can handle that load. They maintain absolute dominance in data throughput. The metric you see here, TBS, refers to terabytes per second, a measurement of how fast massive amounts of data can move through a system. Because NVIDIA has a 2-decade head start in optimizing this hardware-software loop, traditional rivals simply struggle to match their speed. To capitalize on this demand, NVIDIA recently executed a 10-to-1 stock split. A stock split divides each existing share into multiple new ones, making the individual stock 10 times cheaper for retail investors to buy, without altering the company's total market value, which ignited a massive wave of public investment. The physical frontier of their technology continues to expand. NVIDIA GPUs are currently generating highly accurate digital twins of human organs for surgical practice, and they are rendering the complex physics required for the metaverse. From a diner booth in 1993 to providing the underlying hardware for 30% of the cloud-based internet, the original gamble on parallel processing has moved from a niche gaming tactic to a global standard. As these machines grow exponentially smarter and more capable of building realities we can't yet imagine, you have to wonder what impossible architecture Jensen Huang is sketching out today.